Picture this. You're applying for a job. You have, like, the perfect resume, the exact right experience, glowing references.
Right, the whole package.
Exactly. So you submit your application online, and within seconds, you are just automatically rejected.
Yeah. Ouch. Yeah.
Right. And not because you aren't qualified, but because a piece of software looked at historical data, noticed that mostly men had been hired for this role in the past,
Yeah.
and just systematically downgraded your resume, simply because you are a woman.
I mean, it sounds like a dystopian sci-fi plot, but it is actually the documented reality of what happened with Amazon's secret AI recruiting tool back in 2018.
Yeah.
They spent literally years building a system to automate their hiring pipeline, only to realize it was, teaching itself that male candidates were just preferable. They ultimately had to scrap the entire project.
Okay, let's unpack this.
Yeah.
Because what is wild about that Amazon story isn't just the fact that the artificial intelligence showed bias. It's the mechanics of how that bias made it all the way to deployment.
Yeah.
I mean, it wasn't a rogue algorithm making its own decisions, and it wasn't just a random math error.
No,
It was a massive systemic organizational breakdown.
Mhm.
They built this highly complex system, and nobody, literally nobody, in the entire corporate hierarchy was formally assigned to test it for gender bias before they just turn it on.
Exactly. The failure was entirely structural. You can have a room full of brilliant data scientists, but if there's no formalized governance checkpoint telling them to stop and validate the outputs for fairness before the system touches real human lives,
It just goes off the rails.
right, the technology will just scale historical inequalities.
And that actually brings us to the core mission of today's deep dive.
Mhm.
We're looking at a comprehensive practitioner's guide authored by Dr. Jonathan H. Westover.
Mm-hmm.
And this guide focuses heavily on embedding fairness into AI governance. So today, we are mapping out exactly how organizations can stop AI bias before it happens.
Which is huge.
Yeah, we are moving way beyond the idea of just, telling engineers to write better code. We're looking at how to build robust, inescapable organizational guardrails.
And I think the urgency surrounding this just cannot be overstated. We are looking at a massive regulatory hammer that is actively coming down on companies worldwide.
Oh, absolutely.
Take the EU AI Act, which went into effect in August 2024. It aggressively targets what it calls high-risk AI. So systems used in areas like employment, credit scoring, healthcare, law enforcement.
Right, the big stuff.
Exactly. And if a company fails to comply with the governance requirements, the penalties are just staggering. We are talking about fines up to 35 million euros or 7% of their global annual turnover, whichever is higher.
Wait, 7% of global revenue?
Yeah.
I mean, that is a company-ending fine for a lot of organizations.
It really is. And furthermore, in the U.S., enforcement agencies are aggressively utilizing existing civil rights laws like the Fair Housing Act and Title VII of the Civil Rights Act to go after algorithmic bias.
Okay, so they're using old laws for new tech.
Exactly. And the critical detail here is that under U.S. civil rights law, intent does not matter. The legal standard operates on something called disparate impact.
Disparate impact. Meaning what, exactly?
Meaning, if your AI disproportionately screens out a protected class, your organization is liable, even if your engineers had the absolute best intentions and were, entirely unaware of the bias.
Wow. So the stakes are sky high, the financial penalties are astronomical, and yet major companies keep failing at this, which leads us to a fundamental myth about how artificial intelligence is actually built inside these giant corporations.
Ah, yes, the myth of the autonomous tech team.
Right. I know that before diving into this research, I was pictured like a team of genius data scientists sitting in an isolated room, writing code.
Just typing away in the dark.
Exactly. Testing the models, maintaining absolute control over the AI from the moment the idea is brainstormed until it's released to the public.
Right, that's the Hollywood version.
Yeah. But in the real world of a massive corporation, isn't building AI more like a corporate game of passing a hot potato?
A hot potato is a great way to visualize it, honestly. And the problem is, every time that potato changes hands, a little bit of accountability just drops to the floor.
Yeah.
Dr. Westover cites extensive research by Veal and colleagues that maps out how this technology actually travels through an enterprise. An AI system doesn't just live with the tech team.
Where else does it go?
Well, it starts with business executives, passes through procurement, goes to the legal department for review, hits vendor management, gets audited by compliance, and finally lands in business operations for deployment.
Okay, so if a single piece of software is passing through, 5 or 6 completely different departments, whose job is it to actually ensure the final product is fair.
And that is the exact vulnerability Veal's research identifies. They point out three massive structural barriers to mitigating bias in corporate environments.
To break those down, what's the first one?
The first is role ambiguity. So, when fairness is theoretically everyone's job, it becomes no one's job in practice.
Oh, wow. Yeah.
The data scientists assume the legal team will catch any discriminatory outputs. The legal team assumes the tech team already ran the mathematical validations. Business ops assumes someone upstream handled all of it. It's basically a corporate bystander effect.
It's a classic case of, I thought you were watching the stove.
Exactly. And the second barrier compounds this siloed decision-making. These departments simply do not communicate effectively.
Like they're speaking different languages.
Pretty much. The data science team might document a statistical flaw or a data limitation in the model's notes, but the legal team reviewing the liability never even sees that specific document.
That's terrifying. What's the third barrier?
The third barrier, and perhaps the most powerful force in any corporation, is organizational short-termism. The business side has a promised launch date. They have quarterly earnings to think about.
Right, the pressure is on.
Yeah.
Right.
When thorough, time-consuming fairness testing threatens to delay that launch, the intense pressure to deploy almost always overrides the governance protocols.
They just tell themselves, oh, we'll fix the bias issues in version 2.0. But, version 2.0 is just focused on new features, and the deep structural bias becomes permanently embedded.
Exactly. Having ethical principles is incredibly cheap. I mean, any company can publish a glossy PDF about their commitment to AI ethics. But structural governance, actually giving an employee the authority to stop a multi-million-dollar deployment until it is proven fair, that requires a massive shift in corporate culture.
So if the problem isn't just the underlying math, how should we be conceptualizing artificial intelligence? Because clearly, treating this like a pure software engineering problem, like building a standard mobile app, is what is getting companies into this mess.
If we connect this to the bigger picture, we have to stop looking at AI as just software and start viewing it as a socio-technical system.
Socio-technical.
Yeah, the research of Andrew Selbst highlights what he calls abstraction traps. These traps occur when software engineers try to abstract away the messy, complex, highly nuanced social world that their AI is going to operate within.
Right. They try to reduce human society to clean, predictable variables.
Exactly. And the most dangerous trap they point out in the research is the solutionism trap.
The solutionism trap, what is that exactly?
It's the deeply flawed assumption that a technical fix, like a better algorithm, a wider data set, a cleaner line of code, can natively solve a deeply rooted social problem without any accompanying institutional change.
Right.
You simply cannot mathematically optimize your way out of systemic historical discrimination.
It's like trying to fix the crumbling, rotten foundation of a house with a fresh coat of paint. You can make the math look incredibly elegant on the surface, but the house is still going to collapse the second you put weight on it, because the underlying structure was never addressed.
That's a great analogy. And
Yeah.
taking that further, to actually rebuild that foundation requires an entirely new blueprint. That is where Dr. Westover's framework comes into play.
Okay, let's get into the framework.
He proposes a strict 7-stage life cycle for building and deploying AI. It's a comprehensive system designed to build accountability into every single step of the process, so, ensuring that the hot potato is never dropped.
Let's walk through how this foundation is built, starting not with the engineers, but with the executives. What is stage one?
Stage 1 is problem formulation. And the most critical aspect of this stage is that it does not belong to the technical team. It belongs entirely to the AI project sponsor.
So usually the business leader or executive who's requesting the AI in the first place.
Exactly. Before a single line of code is written or a data set is downloaded, that sponsor has to explicitly define what the system is going to do, who it might impact, and what the specific fairness criteria are.
And Dr. Westover points to Google Cloud's Vertex AI platform as a prime example of this, right?
Yes, they structurally force business sponsors to document the protected classes involved and the relevant regulatory frameworks before they are even granted the computing resources to start building.
Wow, so it creates a forcing function. If you don't define the fairness constraints and legal boundaries up front, engineers will naturally optimize their models purely for speed and predictive accuracy.
Right, because that's what they're trained to do.
Okay, so once the problem is strictly formulated, we move to stage 2, which is data collection.
Yes, and this stage is owned by a designated data steward.
And their job isn't just to scrape the internet and gather as much data as possible, right? they have to actively audit the data for historical bias using a mechanism called a data card.
Exactly. Microsoft uses these heavily.
I want to spend a second on this because it's actually fascinating how a simple document changes the engineering behavior. A data card is a standardized, mandatory template.
Hmm.
So if a data scientist wants to use a massive data set of past loan applications, the data card forces them to explicitly log exactly where that data came from, its demographic breakdown, and any known historical skews.
Like acknowledging the data comes from a time period with documented redlining practices, for example.
Exactly. It turns the training data from a mysterious, unquestionable black box into a heavily documented, auditable artifact.
Right. The developer can no longer claim ignorance about the flaws in their foundation.
Okay, so with the data audited, the process moves to stage 3, model development.
Yes. This is where the AI development lead finally takes over to construct and train the actual mathematical model.
But hold on, isn't fairness at this specific stage literally just math? I mean, you have the audited data, you write the algorithm, and you balance the output.
You'd think so.
Yeah, why does the development lead suddenly need the legal department and business executives hovering over their shoulder if the algorithm can just be balanced perfectly?
Well, we desperately want algorithmic fairness to be clean, objective math. But the research of Salam Barocas establishes a profound realization. Competing mathematical definitions of fairness are actually mathematically incompatible in most real-world settings.
Wait, mathematically incompatible. Walk me through what that actually looks like in practice.
Okay, let's look at a concrete scenario. Imagine your company is building an AI to screen resumes and hire 100 new employees. You have two different ways to define fairness mathematically.
Okay.
The first is called demographic parity. This means the AI must recommend an equal proportion of men and women. So, if half the applicants are women, half the recommended hires must be women, regardless of any underlying skews in the historical training data.
That sounds completely fair on the surface. Equal outcomes.
It does. But now let's look at the second definition of fairness, called equalized odds. This means the AI must have the exact same error rate for men as it does for women.
Error rate.
Yeah, so it shouldn't generate more false positives, like recommending someone who actually isn't qualified for one gender over another.
Okay, so equal error rates. That also sounds perfectly fair. Why can't we just program the AI to do both?
Because if your historical training data is inherently skewed, say, it heavily favors male resumes because of past human hiring bias. The only way the AI can achieve that 50-50 demographic parity is by actively lowering its confidence threshold for female applicants to hit the required quota.
Oh, I see.
Right. But the second it lowers that threshold, it inherently increases the false positive error rate for female applicants. By forcing demographic parity, you mathematically destroy equalized odds.
Wow, so prioritizing one definition of mathematical fairness fundamentally degrades another definition of fairness.
Yeah.
It is literally an impossible equation to balance.
Exactly. It forces a choice. Do you want equal outcomes or do you want equal error rates? That is not a coding decision. That is a profound value judgment.
Yeah.
It's a legal and ethical trade-off. And that is exactly why a data scientist should never be making that decision alone in a cubicle.
They need executive cover.
Yes. That is why institutions like JP Morgan Chase require explicit model cards for all their reduction AI.
Which document what exactly?
These documents record exactly which mathematical fairness trade-offs were chosen, and they require legal teams and business executives to sign their names to that specific mathematical choice. If the company gets sued for disparate impact, the executives own the trade-off, not the software developer.
That makes total sense. So the executives have signed off, the AI is built, and the mathematical trade-offs are documented. But before we hand the keys over to the public, someone has to inspect the wiring.
Right.
Which brings us to the second half of the governance lifecycle.
Exactly. Stage 4 is pre-deployment validation. The absolute critical mechanism here is structural independence. This validation must be conducted by an independent AI validation officer.
Independent being the key word there.
Exactly. Salesforce models this perfectly. They maintain a dedicated ethics team that operates completely independently from the product development teams.
Here's where it gets really interesting, because the best way to understand this validation officer is to look at a city building inspector.
Oh, good comparison.
Yeah, when a construction company builds a skyscraper, they are not legally allowed to inspect their own foundation. A city inspector comes in, and they have the absolute authority to halt the entire multi-million-dollar project if the wiring isn't up to code.
Right.
The validation officer operates with that exact same authority. They do not report to the product manager. They have zero incentive to rush the launch for a quarterly earnings report.
If the AI fails the fairness stress test, it does not ship. Period.
That structural separation of power is really the only known cure for the organizational short-termism we discussed earlier.
What?
Now, if the validation officer approves the system, it finally moves to stage 5, deployment and integration,
Oh, yeah,
overseen by a deployment manager.
Because releasing the AI isn't just flipping a server switch, right?
Mm.
It's heavily dependent on how the AI interacts with real humans.
Definitely. A model might test perfectly fair in a controlled laboratory environment, but become highly discriminatory in the wild based entirely on how human employees actually use its outputs.
Right. Dr. Westover's guide highlights Anthem, the healthcare insurer, as the gold standard here. They deployed an AI system to handle prior authorizations, essentially predicting whether a medical treatment should be approved or denied.
But they engineered a strict human-in-the-loop mechanism.
Exactly.
So the AI is operating as a co-pilot, not the final authority.
Exactly how it works in practice is that the AI analyzes the claim. If it generates a low-confidence prediction for a denial, it automatically flags the file and routes it for manual review. Real human physicians maintain absolute override authority on any automated denial.
That's huge.
It is. The deployment manager's specific role is to guarantee those operational safety nets are functioning before the system goes live.
Which is an absolute necessity for anything high stakes like healthcare or, criminal justice.
Yeah.
So the safety nets are in place and the AI is in the wild. But we don't just walk away and let it run forever, right?
Far from it. Artificial intelligence models degrade. The real world is constantly changing. A global pandemic hits, economic conditions shift, user behaviors evolve.
Everything is in motion.
Right. An AI system that was mathematically fair on day 1 might be operating on obsolete baseline data by day 300, leading to entirely new biases. That is why Stage 6 is post-deployment monitoring, led by a permanent AI monitoring officer.
So they're continuously watching for a statistical phenomenon the industry calls drift.
Mm-hmm.
Amazon Web Services actually built a dedicated tool for this exact problem called the SageMaker Model Monitor.
The mechanism behind SageMaker is fascinating. It doesn't just watch the code. It continuously samples the live daily predictions the AI is making in the real world and compares the demographics of those predictions against the original approved baseline data.
Okay.
If it detects that the AI's real-world outputs are drifting away from the established fairness metrics, it automatically triggers a high-priority alert.
And that alert doesn't just go to some random IT inbox. It goes straight to Stage 7, the governance committee.
Exactly.
And this isn't some temporary task force. This is a permanent cross-functional board with serious executive power like IBM's AI ethics board.
They review the drift data from the monitoring officer, and if the AI has fundamentally drifted into biased territory, this committee has the organizational teeth to force the company to take a highly profitable system offline, halt operations, and retrain the model.
Wow. Looking at this entire 7-stage architecture, I mean, starting from the initial business sponsor, defining the constraints, moving through the Microsoft data cards, the independent validation inspector, all the way to a permanent governance committee monitoring for drift. It sounds incredibly robust.
It's a massive undertaking.
It is. But I know what a lot of listeners are thinking right now, particularly those at mid-sized companies.
What is the main concern?
This architecture sounds unbelievably expensive and time-consuming. What if a company simply decides, you know what? We don't have the internal resources to build a 7-stage governance pipeline. We're just going to buy a pre-built AI off the shelf from a third-party vendor to screen our resumes. Doesn't that vendor relationship absolve the company of responsibility?
Yeah.
If the software they bought turns out to be biased, isn't that purely the vendor's legal problem?
What's fascinating here is how explicitly modern legislation anticipates and shuts down that exact loophole.
Really?
Yeah. Under both the EU AI Act and U.S. civil rights law, you absolutely cannot outsource your accountability. If your company purchases a vendor's AI to screen your job applicants and that purchased AI exhibits a disparate impact, your organization is the one that gets sued.
Wow.
Your company is the one paying the multi-million-dollar fines.
So basically, you can outsource the coding, but you cannot outsource the liability.
The deploying organization always remains legally liable. So how do you apply this 7-stage framework when you are just the buyer? Well, you have to aggressively enforce it during the procurement process.
Okay, how so?
Your contracts must demand their Microsoft data cards. You must demand to see their JP Morgan-style model cards documenting their mathematical trade-offs. You force the vendor to prove their fairness metrics before the purchase.
And you still have to monitor it.
Crucially, yes, your company still has to execute Stage 6. You have to monitor the live outputs yourself to ensure the vendor's product doesn't drift while interacting with your specific customers.
This brings up the ultimate operational question. How do you actually get an entire corporate organization to care enough to execute all this extra friction? How do you make this massive governance structure stick day in and day out when the business just wants to, move fast and break things?
It all comes down to incentive alignment. Right now, the vast majority of technical teams and product managers are evaluated on two things, speed and accuracy. Like, did you ship the feature by Q3?
Yeah.
If you want durable, lasting governance, you have to fundamentally change the corporate reward system. You must tie the developers and executives' actual performance metrics and their financial bonuses directly to fairness validation and post-deployment monitoring.
It's the old saying, right? What gets measured gets managed. If an executive's end-of-year bonus takes a massive hit because their new AI project failed an independent fairness audit at stage 4, you better believe they are going to prioritize defining those constraints properly at stage 1 next time.
The behavioral shift is immediate when compensation is tied to governance. Dr. Westover notes that even with aligned incentives, it generally takes an organization 12 to 18 months of rigorously applying the 7-stage framework before the company truly matures, the culture shifts, and they start seeing their outcome metrics reliably improve. It is a long-term operational play.
So what does this all mean? If we step back and look at the entire landscape Dr. Westover has mapped out for us today, well, the ultimate takeaway is that unbiased artificial intelligence does not magically emerge from writing more elegant algorithms.
Definitely not.
It requires a permanent paper trail of human accountability.
Yeah.
It is about assigning specific, undodgeable roles, mandating heavily documented data and model cards, and intentionally engineering cross-functional friction into the corporate pipeline.
Friction is really the defining concept here. In modern corporate culture, we're taught to view friction as the enemy, something inefficient that slows down innovation. But in the realm of AI governance, friction is the feature, not the bug.
I love that.
Yeah, that intentional friction, the independent inspector, the legal review, the governance committee, is what prevents the fires, instead of forcing your legal team to fight them after they've already burned down your company's reputation.
Friction saves the foundation.
And this framework matters deeply to every single person listening, because you are the individuals on the receiving end of these socio-technical systems.
Absolutely.
You are the ones submitting the resumes, applying for the lines of credit, and trying to get approved for healthcare treatments. You are the ones directly affected by these structural choices, by whether a corporate executive decided to skip stage 4 validation just to hit a quarterly launch date.
The real-world stakes are profoundly personal. And I want to leave you with a final thought to mull over, looking beyond just the software. Today, we've explored how organizations are building these massive, 7-stage, multi-million-dollar governance structures, complete with independent auditors and statistical drift monitoring, just to ensure their software doesn't exhibit bias.
Right.
But what about human decision makers? I mean, if we are finally admitting that historical data is inherently flawed and we are forcing our algorithms to mathematically prove their fairness, shouldn't we eventually require human managers to do the same? Should human recruiters and loan officers be legally required to pass the exact same statistical fairness audits and formally document their internal biases before making a decision? If we are holding our code to this impossibly high standard of documented fairness, maybe the next logical step in our society is holding human intuition to the exact same mathematical scrutiny.